Okay, today's learning goal. We are looking more closely at the steepness of a line. And in fact, we're going to come up with some different words for steepness of a line. And the words are all going to seem very familiar. And I need to tell you, this is one of the most important concepts in grade 9 math, is what we're talking about, the steepness here. I didn't say it was difficult. I actually don't think this is too difficult what has to happen here. There's a few little details you have to understand, but it's just very important to everything we do later. So I want to come back to this page and write a couple extra words on it when as the lesson goes on to add on to this. So to look at this a little more closely, we want to talk about what happens to lines as the rate increases. And that might be obvious to you as soon as I say that, but I want to go walk through it. So it says write the equation of each line indicated, then graph the lines on the given graph. So it says start value and rate 1 and 1. So let me just get a pen going here. And if I was going to write an equation in y equals mx plus v that has start value 1 and rate 1, I'd write y equals 1x plus 1. Not too complicated there. And what 1x plus 1 will look like, it'll start on the y-axis at 1, and then it'll go up by 1s. And I've drawn a lot of dots on there just to get the idea. For you, you won't need to draw this many dots. You'll just draw a few dots. And once you have enough that you can put your ruler on the page and draw a straight line, then you'll be done. So here I've drawn enough here that I can make sure I draw this straight line without a ruler. And there's the line. And I put little arrows on the end of it to indicate this line actually keeps going off the page, but I've only got this much room on the page. And so that line is y equals 1x plus 1. And when you have more than one line that you're going to graph on a set of axes or on a graph, here we want to label each one. So I've labeled that one y equals 1x plus 1. And to really see in your screen, that one was purple, so I'll do the next one in blue. The next one it wants is start value 1, rate 3. Now, let's just be careful, just in case the last lesson wasn't perfectly clear. When we have rate 3, the rate goes with the x. There's where the rate goes, and the start value is the number all by itself. So this line that I'm doing starts at 1, but then goes up by 3s. And when I go back, it's got to go down by 3s because I'm going backwards. And there's the next line. Hopefully you'll use a ruler. Something like that. And that's y equals 3x plus 1. I'll label it on here. Like I say, when you have more than one line in a graph, you really want to label each one so you can see them. Okay, and you might already see exactly what's happening here. You might have given it all away. And really makes my point that steepness is not very difficult. It's just very important. That's all. Okay, so now rate 5. So the rate goes here, y equals 5x plus 1. I've changed colors again so you can really see here. And so this line starts at 1 and goes up by 5s now. Oh, that goes right off the page already. Right about -4 there. And you can see it actually doesn't, the other lines I had all these points that I used, and you really don't need all those points. A couple of points will do to draw the line. And I really hope you use a ruler. On my screen here, it's not quite so easy to draw those straight lines when I'm in Microsoft Word like this, but I hope you're using a ruler on all your lines so you don't get little, like I see a mistake on mine over here. You see how this doesn't go through this point here? We really want them to go right through the point. So when you use a ruler, that should happen, okay? So really try and make yours nice and neat. And label all of them. So after all that, some pretty easy conclusions, I think, here. As the rate gets larger, the line gets steeper. For this reason, we often call the rate slope. So here's a new word for rate. Rate and slope. I won't say they mean the exact same thing, but they will be the exact same numbers. When we're talking about a question, we might talk about what the rate of the situation is. And when we go to graph it, we'll say that's called the slope on the line. So they really are the same thing. So up here, when I want to talk about steepness, it means I'm talking about the rate, but I'm also talking about the slope. Those two numbers come out to be the same thing. Whatever the rate is, that's what the slope will be. And here, as I got higher and higher rates, I got higher and higher slopes on the graph, meaning I got steeper and steeper graph. Maybe you're not surprised. Okay, so we're going to do the same thing with negative numbers. So if that is perfectly clear, you're going to find this fairly boring, but you're going to learn a little bit about negative slopes here. If it wasn't quite clear on the last activity, then hopefully by the end of this activity, you'll be like, okay, now I do get it. So it says go with the first equation, go with start value 1, rate -1. So now I'm going y equals -1x plus 1. So I'm starting at 1, but now instead of going up by 1s, I'm going down by 1s. And that's an important concept in all this, is that negative slopes means we're going down as we go left to right here, as opposed to going up like I was in the last one. So negative slope and negative rate means we should see the graph go down when we go left to right. Always left to right we talk about. We're going down, left to right like that. I know it's going up when you go right to left. Yeah, I get that. But we'll always go left to right because actually oftentimes this axis will be time. And that's why we go left to right. So in a lot of applications, the axis, the independent axis will actually be time. So that's why we always look left to right. So negative slope means means going down, left to right. There's the first one. I forget what color I used in the last one. I think it was like a blue. And so now, rate -3. So instead of y equals -1x, I go -3x. And so I start at 1, and I go down by 3s. Something like that. And when I go backwards, I got to see where it came from, which means I sort of got to go up by 3s. And so now this is negative slope because it's going down left to right. I'm going to say that again and again because that's how we decide whether something's negative. We go down left to right. Oh, and now I've noticed that I'm drawing more than one graph on this axis. So when I do that, I really want to label them. We sort of let you away with it. If there's only one graph on there and you don't label it, well, okay. We don't love that, but that's okay. But as soon as you have two graphs on there, you really want to put a label on each one. And the last one, I think I went with like a red. Let's see, y equals -5x plus 1, because this time the rate is -5, so it starts at 1 and then goes down by 5s. I'm going to go back this way. It goes up something like that. And again, my lines aren't perfectly straight. Doing the best I can on my computer screen here, but yours should be. You get a ruler and draw those very, very straight, and then label them somewhere. So I'm going to label this one y equals -5x plus 1. And I hope you can see, as the rate gets larger and negative, the line gets steeper. So larger numbers, whether it's positive or negative numbers, means steeper graphs. For this reason, we often call the rate slope. Those two things essentially mean the same thing. Slope when we're talking about a graph, rate when we're talking about the question in words, probably. Okay. So, finding the slope in different situations. This is the key part of this lesson. That previous part was just to introduce the word slope and see why we call it slope, because slope indicates how steep the line is. But now we're actually going to now find the slope in different situations. And we say find slope, that's what we were calling rate before. And we'll call them back and forth. We will call them rate sometimes, but slope is really the word we use when we're graphing, which is a lot of what we're going to be doing next. Now, this particular question I'm going to talk about in a different way, because you could do this question with yesterday or last day's lesson, no problem. You can look right at it and say, oh, I can see what it's going up by. I get that. But I'm going to talk about it in a slightly different way to get ready for different examples. When I look at this, there's a point right there at 0, 2. And then the next good point I see is right there. It's right at 1, 5. And what I notice is that as I went over 1, it went up 3. This little triangle will be very helpful. In this particular example, you might look at it and go, I don't need your crazy triangle. And I agree with you. But again, I'm getting ready for tougher examples. So then what we say here is slope equals 3. Because for every 1 you go over, it's going up 3. If that seems really boring to you, great. You're in the perfect place to get ready for the next example. I should mention here that mathematicians use a letter for a slope. We use the letter M to represent slope. And the reason we use M is because the first mathematician that really did a very, very good textbook on this topic was French. And so to him, monter, the verb monter in French was to rise or to go up, something like that in French. And so he used the short form M for rise, and then it just caught on. And for hundreds of years, that's what we've used to represent slope. If we were going to redo this now, sort of in English, we might use S for slope, but now S is used for other things and so on. So you're just going to have to play along. Hundreds of years of mathematics has leaned towards using the letter M for slope. So I introduced that to you right now. M equals 3. Now, if you're really with me, you might go, oh, that's why yesterday you called it y equals mx plus b, because the m was the slope. And that's exactly right, is that we were setting up for that. Didn't explain that all that well last day because there's enough going on already, but that's what's happening there. Okay, now, number 2 switches gears a little bit on you. And when we take a look at this example, I hope everything that happens is going to be obvious, and when that's all done, we'll be ready for tougher examples. Alex makes $87 in 4 hours selling headphones. Find his rate. This seems like a completely different example, but we can do it. It's still the same type of rate we've been talking about. It is. But this time, instead of giving the rate for each hour, it's given it for 4 hours. Well, hopefully you know what to do here. To get the rate, all you do is take how much money he made, $87, so how much he went up by, and I'm really trying to change my words slightly to get it more into a graphing type thinking. His money went up $87, but that happened over 4 hours. So I've got to divide it by 4 to find out how much for every 1 hour. So when we talk about the rate really is for 1. For, in this case, for 1 hour. And when it's given for 4 hours like this, we got to divide it. And lots of times we'll leave this as a fraction in this chapter. I won't in this one because it's a money example, and most people are expecting a money example. When I type that in my calculator, I get $21.75. But the big thing I want you to get from that is, this is sort of how much it went up, and this is sort of how long that took. And we're going to use that kind of thinking to handle slopes in tougher situations than in the first example here, where it was just going up by nice 3s. Okay, example 3. Find the slope in these situations. Now, I'm going to try and tie those two examples together and try to use all that thinking to find the slope. And maybe I'll just try and zoom in a little bit here on this graph. Okay, so the key to be able to find slope on these graphs is to find nice points. And by nice points, I mean ones that go right through nice grid lines. So now that I've zoomed in here, I can see there's a nice point. It goes right through a grid crossing. I know that's exactly at 0, 0. Now, I'm going to first draw a point here and then erase it because I don't like this point. See this point right here? It's sort of in between. And you might go, oh, well, I know, it looks like about 2.2. And yeah, it is about 2.2. And that's not a bad estimate, but it's not the greatest point to use because it doesn't go through a nice grid crossing. If you look over and scan across, you'll see that this point here goes through a grid crossing, well, a little better. It's a lot closer to going through a grid crossing than the previous one. So we want to find the points that are going through the grid crossings as best we can. Now remember what I said. The other answer looked like about 2.2. And the answer we'll get is about 2.2. Now, here's the only problem. I see that it's gone up by 7. But that didn't happen every square. That happened over 3 squares. So like the headphone example, it's like they made $7, but that took 3 hours. So that's where this division comes in to find out how much for each one. We've got to take 7 and divide it by 3 to say how much for each one. And if I divide that, we won't do decimals too much in this chapter, but if I divide it, I get around 2.33, which is close to the answer I would have got before, but this is a little more exact because I used points that were right on the grid lines. Okay, so I want to circle this answer here and let you know that even if you don't like fractions, fractions will be very helpful in this chapter. I'm not just saying that because I'm being a math nerd. Really, I'm telling you that the fractions, you'll like the fractions better because we don't have to do any crazy things with the fractions here. We don't have to add, common denominator, multiply, all that kind of stuff. We don't have to do any of that. We just need to get these two numbers, the top and the bottom of the fraction, and it'll be nice when it's in fraction form. Okay, I hope you sort of get the idea there. There's a set of steps here. I'm going to write those set of steps out in a minute. If you're like, oh, I'm getting lost in all this. I'm going to do a few examples, and then I'll write down a set of steps for you. Here's another example. It says find the slope. The first step is find some good points. There's a good point. The reason it's a good point is it goes right through a grid crossing. I know exactly where that point is. It's at 0, 3. And then I'm going to pick some points that aren't good choices. That's not a great choice because it doesn't go through a nice grid crossing. I don't know exactly what that number is. I'd be estimating. This one, on your printout, it might look like this is a good point, but I hope you can see on mine, I've zoomed in a little bit, that it really doesn't go through the grid crossing exactly. It wouldn't give you a bad estimate, but it's not the greatest. There is a great point here. If you look across here, I'll just zoom back out a little bit, this point really goes through a nice grid crossing. So when you're finding slopes, you really want to start with finding nice points that will allow you to estimate as little as possible. Now, if you're right with me, I'm about to make a mistake. Okay, I'm going to go back and fix it. So if I do something here, you're like, what are you doing? Because you're right with me, that's okay. I'm going to come back and fix it, okay? So this graph goes down 3. So its slope, it goes down 3 right there. But that takes 5 to do it. So if it was a headphone example, we'd say, oh, they lost $3 for every 5 hours. So it's not 3 every 1. The rate isn't 3. It's 3 for every 5. And again, sometimes we'll go to decimals there, but I'm going to start moving away from that and leave it as a fraction because you're just going to have to trust me that fractions are going to be nicer here. So 3/5, that is the rate here. That is the slope here. Okay, now here's the mistake I made. This graph was going down. See, this one was going up left to right, so this was a positive slope. This one over here is going down left to right, so we call that a negative slope. Let's think about if this is a graph of your bank account. Which graph would you like to see in your bank account? You want this one. Yeah? You want positive things going up. This is the one on the right-hand side is negative. That's going downwards. So it's always left to right we look to decide the positive negative thing. And so this slope is negative 3/5 because it's going down. You could again get that as a decimal, but we're not going to. Okay. So find slope of each of the following lines. Now find slope in different situations. I hope I've set this up so we can handle this example because all the previous examples had the nice y-intercept going there. You know, the first point was right on the y-axis. This number 4 doesn't do that. It doesn't go right through a nice point. So it's awfully tempting to go, oh, I'll use this point. It's not a very good point to use because it doesn't go right through a grid crossing, so I'm not going to use that. I'm going to look around and try and find very good points that go right through grid crossings. And the first point I see that's a really good one is that one. And again, if on a quiz or test, the printout is such that you use slightly different points, we're going to work with you because it's all going to be an estimate anyways. Just use points that are as close to a grid crossing as you can find. Those are going to work good. And looking over here, there's not a good one there. I don't like that one, so I'll just erase that. No. Oh, way back here is the next one I see. That's a really good grid crossing. And I'm going to tell you, drawing these triangles, I've been doing that without really talking about it all the way along, is a great move. This thing actually has a name. It's called a rate triangle. And I'm going to talk more about that in just a minute, where I'm going to review these steps for you. But this rate triangle really helps to frame where you're at in all of this. And when I do that right there, I find that I get slope 11. So rise 11. It's going up by 11. And how many squares did that take? That took 10 squares. You'll notice that online, the completed version of this note actually has 12 and 11 as the 2 points I used, because sometimes it's not easy to see exactly where the grid points go through. And 12 over 11 and 11 over 10, those are very similar slopes. So sometimes the graphs, it's going to be a bit of an estimate. So it's not going to be perfect all the time when we use graphs. And that's one of the reasons why we often switch to equations and so on, is because the answers can be more exact than they are from a graph. But in this case, I get slope. It went up 11 for every 10. Okay, so it wasn't 11 every single time. It didn't go up 11 every single time. It took 10 squares before it went up 11, so the slope is 11 over 10. And again, I'm going to leave that as a fraction because I want you to move more and more to using the fractions. You're going to like that better. Okay, one more example before we review what we've learned so far. Again, using the y-intercept, the point on the y-axis there, is not the greatest point because it doesn't go right through a grid crossing. So you go out and you find some points that really look like they go through grid crossings. I like this one. It seems to go through a nice grid crossing. And then this one over here seems to go through a nice grid crossing. And what that means is that this line has gone down 3, and I've learned my lesson about negatives. That's going down 3 because it's going down left to right. And then, but that took 5 squares to do that. So the slope is -3 for every 5. And I've learned my lesson about negatives there. So watch out for that. That's probably the number one mistake people make with slope when they're first learning it, is remembering that lines that drop off left to right here are negative slopes. Okay, as promised, to review. Okay, stop. How do I find slope? Most important part of the lesson. You definitely want to get this stuff carefully down. How do I find slope? Slope equals rise over run. There's an awesome poster in my classroom when I do this class in regular time, and it has this saying, and I'm going to write it here. Slope is easy and fun. Just remember, rise over run. If that's a little confusing to you, the example that really started this whole thing was this example here with Alex and his headphones. $87 in 4 hours. 87 was the rise. 4 was the run. 87 was how much did we go up? 4 was how long did it take? And so whenever we're doing slope or rate, and I'm going to put that right on here, we're going to take the rise and divide it by the run. How much did we go up by divided by how long did it take? Now, some things we learned about finding slope is we want to pick good points. So we want to pick points that are right on grid crossings. Maybe we want to use the word intersections there, where the grids intersect, because then we won't have to estimate them. And we want to draw a rate triangle. The science people are going to be so happy that I use those words, rate triangle. They use that all the time to help, and draw a rate triangle to help. And what we mean by a rate triangle is we're going to have these points, and we're going to have a line, and we're going to connect this up, and the rise will be right here on the triangle, and the run will be right there on the triangle. And that's such an important triangle moving forward. And if you're like, oh, why is he saying this is so important? It seems so easy. Oh, well, easy things can be important, and important things can be easy. In this particular case, slope isn't that difficult, but it is so fundamental to all the math we do over the next few years. So going right back, and now that we have a set of steps to do these questions, I want to do a couple more examples really to nail this down. The steps were find good points. So here I've got a nice good point at 0, 1 here. And then when I look over here, there's already another nice point right here. And so there's my nice rate triangle. It went up 2 for every 3. So my M, ooh, look at me getting fancy. M. Put that in the box up here. M is used to represent slope. Because that French guy, Monte, his name wasn't Monte, the verb Monte, yeah. So then rise over run, 2 over 3. And to really get fancy in the next one, I'm going to write the formula every time. Sort of gets you that measurement feel where we write a formula and then we fill in the answers. So it says, here's how you really might do this, is find the slope. So you go M equals rise over run. Now we're really getting mathematical here. So now to find these points, wow, some complicated points here. I really got to look at this and try and find some nice points here. I think this is a pretty nice point. And I think this is a pretty nice point. I draw my rate triangle. Now look here, be careful. Be careful. Because look what's happened here. This example has a weird scale. Take a look at that scale. It's going up by tens. So it's not just count the squares here. The slope isn't 1, 2, 3, 4, 5, 6, 7, because each of those squares is worth 10. The slope is 70. Sorry, the rise, not the slope. Whoa, whoa, careful. The rise is 70. And the run, look at the scale. The scale, it's 2s. So it's not 1, 2, 3, 4 squares. It's 2, 4, 6, 8 across there. So watch the scale. Ooh, let's put that over in some notes here. Watch the scale. That can trip you up here if you're not watching the scale. You're like, why would they mess with the scale here and just try and screw us up? And that's not really what happens. The data that you gain from whatever field you're going into, whether it's science, computers, finance, whatever, the scale will be based on what kind of data you get. So that scale won't be something that's meant to trick you. It's meant to help you. But when you go to look at it, you got to watch out for it. So the rise here is 70. The run here is 8. Ooh, that fraction reduces to 35 over 4. Now, I hope you were thinking the whole time, yo, you made a mistake all the way through. I hope you noticed. Because I really want to highlight that because it's an often made mistake, which is not noticing that the rise here was negative. So actually my slope is negative 35 over 4. So one more over here. Watch 4 negatives. So something like that, that's positive slope. Something like that, that's negative slope. Little diagram there to help you out to memorize all that stuff. How did I do? M equals 35 over 4. Good. And I notice I didn't go to mixed form here. I didn't go to decimal here. We're actually going to like it just like this. And as the lessons proceed, you're going to see why we're going to like slope just like that in improper form is great for us. Okay. I hope that is all very, very clear because the next 2 slides really ramp things up a notch and really go where we need to go with all this. So we got 2 more examples and then a final summary where we put all this stuff together and give you some final stuff to look at. Take a look at this example. It says determine the slope of the line that passes through 9, 4 and 15, 11. And apparently we want to get to the point where we don't have to graph these points all the way out to be able to find the slope. And I'm going to partially cheat here, and I'm going to draw a little grid and get an idea where these points are to try and help us to manage this situation so that maybe we don't have to use the grid anymore. Not that I don't like grids, but is there a way to handle this situation without building a grid? I'm not going to build a perfect grid, just a little diagram to see what the heck is going on. The first point is 9, 4, so it's, somewhere in this range here, and that's 9, 4. And the second point is 15, 11, and I can't draw it perfectly because I haven't made a perfect grid here, but I'm not trying to do that. I'm just trying to get a feel for where this point would be. If it's 15, it's got to be farther over to the right here, and if it's 11, it's got to be higher up, so it's somewhere about there. And you can nitpick about where I put it. You can look at that and go, oh, you didn't go up high enough, or you didn't go right enough. And I totally get all that, and it's not the point of what I'm trying to accomplish here. What I want to look at is then go, can I look at those points and figure out what the rise would be and what the run would be? And the answer is a giant yes. So take a look at this. I'm going to draw my rate triangle on here. And can I figure out how much that went up? I'm going to use my highlighter here to highlight some important information. This one started at y value 4. And this one ended up at y value 11. It went from 4 up to 11. How much is that rise if you go from 4 up to 11? Well, hopefully the number pops in your head. You're like, oh, it went up 7. Now, I just want to give you a more powerful weapon to handle it. Because in this question, the numbers were 11 and 4. But what happens if they're 72 and 655? Or 32.8 and negative 24.6? Then it's not quite so easy to get the answer in your head. So in this particular question, what I'm going to do might seem like overkill, but it's going to help you. I'm actually going to find that rise, I'm going to take the 11 and subtract 4. That's how I'm going to come up with rise. Take the second y value there and subtract the first y value. Now the run. Let me do a different highlighter there to do the run. Do green. Started at 9 and went up to 15. And again, hopefully you look at that and go, okay, if I go from 9 over to 15, I've gone 6 to the right. And again, that's fine in this particular question, but as the numbers get bigger, or crazy decimals, we're going to need a more powerful weapon. And here's my powerful weapon. I'm just going to subtract those 2 things because that will find those numbers. If you think that's overkill, well, again, we're getting ready for bigger numbers here. And when I go 11 minus 4 on the top, I get 7. I go 15 minus 9 on the bottom, I get 6. Maybe you could look right at those and see that, but I'm giving you another way to find slope. Here is this this is the best equation of the year by far. If I said a different equation was better, or later on we say this equation is better, those are complete lies. This is it. This is the one. M equals y2 minus y1 over x2 minus x1. If it's not clear how I got all that stuff, I'm going to explain it in just a second. And put that in a big heart because we love this equation in grade 9. And what we mean by that is, what I did is I said, okay, this first point had an x value. I'm going to call that x1. And it had a y value. I'm going to call that y1. And the second point had an x value. We called x2. And the second point had a y value called y2. And to get the rise and run, all we did was took the second y value and subtract the first y value. That's the rise. And to get the run, we take the second x value and subtract the first x value. Okay, I don't expect that to be perfect the first time through. But if you sort of get it, then we're going to do another example, and then the homework is so important. It's so important you practice these steps. And if you're having trouble with slope questions, come back to this important, gets the big star, most important example of the day. And I'm right here. I could do a grid to do this question, but I'm not going to. I'm just going to write if needed. So if you're having trouble with a question and you want to do it on graph paper, it's fine to do it on graph paper, but we want to be able to do these without going through that step. Here is the steps. Come back to this example, come back to this part of the video when you're having trouble with slope. When they give you the points, write down this new beautiful equation. Y equals y2 minus y1 over x2 minus x1. Write down that formula, tape it to your wall, make it the wallpaper on your phone, do something. Have that memorized. How do you use it? Okay, this first, I do all these steps as you're doing these questions within your homework. This first point has an x and a y value, so I'm going to call them x1 and y1. It's the first x value and the first y value. And this second point has an x value and a y value. We'll call that x2 and y2. And then I just fill them in the formula. The formula says y2. I look over and go y2 is negative 12. And then I go subtract. I look, and there's y1. Y1, I look over at my labeling, and y1 was 5. x2, I look at my labeling, and the x2 was 10. And the x1 was negative 4. Watch out for this. It's subtracting a negative because the x1 was negative. Get out my calculator if I have to. Negative 17 on the top and 14 on the bottom. M is negative 17 over 14. I didn't use the word slope once and all that. I used M, and so you're going to find that mathematicians use that interchangeably. We always use M to represent slope. So, if you're having trouble, it takes practice. Practice those and follow those exact steps. Everything I labeled, like let me highlight all the important things I did. Labeling these was important. Writing the formula was important. Carefully writing it so I caught negatives was important. And you might have to reduce the fraction at the end, but this one didn't have to. Okay. Very important example, very important practice. Please, please, please go through those carefully and watch out for all those little steps and watch this part of the video again and again. Notice it handles the negatives for me. I didn't have to watch out for the negatives. It found out for me that this graph would have been negative. Because if you think about it, negative 4, 5 would have been up here somewhere. 10, negative 12 would have been way down here somewhere. And you can see that, oh, that'll be a negative slope. And this formula catches that. It takes care of it all for you. So it's so nice like that. Some review. What is slope? Slope is the rate. So new word for rate today, it's the rate. And when we talk about slope, we're talking about how steep the line is. And I want to draw this thing again. Positive slopes go like that. Negative slopes go like that. And what is slope? It tells you how to graph a line. It tells you how much to go up by every time. Final summary, how do we calculate slope? Well, we might use rise over run. There's a lot of examples that were on graphs. And when we're on a graph, we can just use rise over run. I've got nothing against rise over run. Probably use a rate triangle. And there were some steps to exactly how to handle that. But the other way we've got to do this now is m equals y2 minus y1 over x2 minus x1. And if that busts your brain, I get it. The first time through, that can be a little mysterious. It's going to take rewatching this part of the video, this last example here with the big star there. Whoops, jumped on me. Where'd it go? Right there. It takes watching that part of the video again and trying the different examples and checking your answers. Okay? Lots of practice here. This is going